Welcome, Stephanie. Welcome, Kamani. Oh, I was going to get annoying quick. How did I solve this yesterday? Welcome, Jawad. Welcome, Gianna. And welcome, Fatima. There we go. Welcome, Tyrese. We're all heading to the do now. There are 4 questions on the Google document. Make sure you complete at least 3 of them in the time, although you should all be able to get 4 done. Thank you so much to Stephanie, Jawad, Gianna for having their video on. Welcome, Sandra. And welcome, Ahad. What is this? Yes, Kamani, I did get the assignment. Thank you. Let's go 3 minutes to complete the 4 problems in the do now. Welcome, Haidia. Welcome, Leah. Let's take a look at this and do now. Welcome, Beatrice. Welcome, Ramir. We're going to be coming back together in 1 minute. Make sure you have your answers to the 4 questions on the do now. I am going to call on students to respond. If you came late today, make sure you are logging in a little bit earlier tomorrow. You don't want to be late for the quiz. Great. And just finish up your last thought. I'm going to take a look at a couple of these on Google Classroom, and then we'll come back together. Oh, very thorough. Good, 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 good. All right, and track back up here, students. Let's come back together. If you're still typing on your response, please stop. And let's go through this. I'm going to call on, let's see, to answer question A, I'm going to ask Beatrice. For question B, I'm going to ask Diana, although I didn't see her enter today, so we might jump to someone else. For question C, Kamani. And for question D, Stephanie. Let me just double check for Diana. I don't see Diana, so Leah, I'm going to need you to do question B for us. And let's start with Beatrice.
The answer for letter A is that the temperature of the flask will decrease because the reaction is endothermic.
Okay, good. And what happens to energy in an endothermic reaction?
As energy in an endothermic reaction, as it goes on, it absorbs the energy.
What absorbs the energy? What? Just rephrase that so I can understand.
The system absorbs the energy.
Good, very good. Thank you for the proper use of vocabulary. And then Leah, could you give us your response for B?
Okay. For B, I had said that the sum of the bond strengths in the products is greater than the reactants. Since in the products it is a combination of nitrogen and hydrogen, and that's hydrogen bonding. Wow.
I'm gonna pause you right there, Leia. The justification I need here is in terms of the enthalpy. So what can the enthalpy tell you?
It's a positive enthalpy. So the sum of the bond strengths of the reactants is.
Well, think about it, it's a positive enthalpy. So we know that the system is absorbing energy. If the system is absorbing energy, then it takes more energy to put the molecules together than it takes to break them apart. So what does that tell us about the energy of the bonds of the products, which are coming apart, and the reactants, which are coming back together?
That means the sum of the bonds of the product is greater than the sums of the bonds of the reactants.
The sums of the bond energies. Can you just rephrase?
The sums of the bonds of energy in the reactants is less than the sum of the bonds energy in the product.
Fantastic, thank you. Very good. Okay, and actually we're running a little bit late, so I'm not gonna call on the other two students. Instead, here are the correct answers. They're shared to your screen. Just go ahead and take the next minute to rectify or adjust your responses to make them match A, B, C, and D here. Okay. So if you didn't quite get this, I'm going to share this PowerPoint later. For now, we're going to move on. We have a bit of a tight day today. So first thing I need you to do is a stop and jot to get us all thinking. Just type this to me in a private message in the chat. First, how is the enthalpy of a reaction related to the bond energies of the molecules in the product and reactant? If you're paying attention to me and Leia's conversation, you should have that. And then how can we predict the sign of enthalpy of a reaction based on the experimental data? And welcome, Abigail. Just typing this to me in the chat. Question 1, enter, and then question 2. A question, Kamani?
Oh no, sorry, I forgot to put my hand down.
Good, getting some responses in. We're just typing in the first question, then entering, pressing enter, and then you can move on to the second question, but I want to read your question 1 responses. Good, thank you. Good. So many thorough responses with such great vocabulary. Fantastic. All right, we're going to take just 30 more seconds, and then I'm going to ask, let's have Kamani share out his response for the first question, and Jawad share out his response for the second question. And then I might call on some other students as well. Okay, and let's come back together. Just press enter on whatever you have, even if it's an incomplete response. I want to be able to see it. Wonderful. Thank you. Thank you. So, and then let's start. Kamani, can you share out your response to the first question?
All right. So for the first question, I said that if the bond strengths of the reactants are greater, then the enthalpy would be positive, and if the
Yeah,
bond
greater than what?
strength greater than the bond strength of the products, then the enthalpy would be positive. And if the bond strengths of the products are greater than the bond strengths of the reactants, then enthalpy would be negative, according to the equation sum of bonds broken minus the sum of bonds formed, enthalpy of bonds formed.
Very good. And then, Jawad, can you share your response to the second question?
My response was that we can predict the sign of enthalpy by seeing the heat transfer of the system, where the reaction is happening and the temperature of the surroundings compared to the system. And we can use a thermometer to measure the temperature change and see what change is happening to the system and the surroundings.
So if my system, or rather, if the temperature of my surroundings was increasing, what would that tell me about the enthalpy?
If the temperatures of your surrounding is increasing, that means that heat is being released from the system, and therefore the enthalpy would be negative because it's an exothermic reaction.
Good. Very good. So let's keep going. We're going to talk a little bit about the study guides that you submitted for homework last night. Thank you so much to those of you who got those in on time. If you didn't get it on time, still get it to me. It's a great resource, and you want that feedback that I can give you on your study guide so we can have the best possible study guide. Towards that end, there's a couple things I did notice while looking through your study guides. This slide we've already seen before. If you just want to zoom in on this bottom corner here where my mouse is playing, we no longer have to worry about any of this information. This is the stuff that is not covered on the test. So something big that is no longer covered are electrochemical and voltaic cells. I saw quite a few students who put a bunch of stuff on their study guides about different cells, the different equations, what it means. We don't need to know that. Don't include it on your study guide. You don't need to know it anymore. Spend time on the stuff we actually do need to know. The part of thermodynamics, that is not entropy. That is not the relationship between thermodynamic favorability and Gibbs energy. That is not the types of electrochemical cells. Don't worry about that stuff no more. Towards that end, I'm going to show, there are a couple study guides in your student handout, a couple of students who got those in early. Take a look at those. I want you to think about two things while you're reading through them. Can you easily find, or three things. Can you easily find the information? Is it a good study guide? How are you going to modify your study guide in response? And one more thing that's not on the bullet. How can you make the study guide better? Three things. Organized. What can you learn? How can you improve? Take 4 minutes to respond to that in your document, and I'll be scrolling through those. Let's make it 3 minutes. Good, Fatima. There are 90 seconds remaining. Make sure you're typing your answers into the box. If you don't do the classwork, you won't receive credit for the classwork. I want to give you points. Hmm. Or is that just my internet connection? All right, and that is time. Please track back up here. Just finish typing whatever you have. Great. And then I'm going to ask a few students to share out about the study guides from the Google document. So first, could I get Chantel to tell me a positive of one of the study guides? And then I'm going to need Fatima to tell me a change she's going to make to her own guide. And then I'd like Sandra to give me one thing that the two exemplars can do better. So let's start with Chantel.
One second. One. You said one positive of a
Yes.
study guide? One positive of the study of the exemplar study guides is how organized they are. So like when they're actually in the test, it's not going to be that hard to find exactly what they need in order to successfully answer that question.
What specifically did one of them do to help with organization, Chantel?
On page 2, the one on the left used like color coordinated like sections. So typically your eyes would follow that. So once you see like the highlighted section that you're looking for, you would look in that section to find what you need.
Good. Color is very useful because our eyes are naturally drawn to it. Then the next student, Fatima, could you answer your change?
A change that I will make would be like not putting so much information in one piece of paper so like it doesn't look cramped up and stuff. Yeah.
Okay. And what's the specific benefit of that?
I mean, it'll be easier for me to find information if all of it is not all together and the handwriting isn't so small. So like it will be easier for me to find it.
Good. Remember, every second you spend looking at your resource is a second you lose answering a question. And then finally, Sandra, how can we improve these study guides?
I think like looking at it, they also included like delta G and entropy, and you said that that's not something that really has to be covered. So ensuring not only are we looking at our own notes, but the notes that show the topics that are going to be on the test to ensure that we're actually writing down proper information.
Good. Thermodynamics is a little tricky because some of it is covered and some of it isn't. So you're just going to want to reference that slide that's posted on Google Classroom to know what to actually study. All right, and that's time for that. We are going to move on. The bulk of the rest of this day is going to be spent in FRQ practice because that's what we're going to have to do in exactly 3 weeks from today. The AP test is almost here. Remember, your quiz is tomorrow. If there are some of your friends who have not been in class, make sure you let them know that the quiz is tomorrow and that's mandatory. I don't want to have to give anyone zeros. I made a Google Classroom post, and I've reached out to your science teachers so they know that you need to be here. But let's talk about FRQs. So FRQs, there are 4 major things we're really going to be focusing on, 4 skills that the AP testers are really going to be looking at. Could I get, yeah, Ramir, can you just read these aloud?
Yeah. So FRQ skills: explain chemical phenomena using models, theories, and representations as particulate and macroscopic levels. Draw conclusions from experimental results. Identify and explain experimental procedures that are aligned to a question and analyze sources of error. Analyze a system with quantitative reasoning. Support claims with evidence and reasoning.
Good, thank you so much. Now remember, these 4 things, good. So all of these 4 things you're going to be tested on. A lot of these we've already been tested on, like we've seen particle diagrams, we've seen larger systems, we've looked at experimental data, although analyzing experiments is still one of our weaker points, so we're going to try and push that going forward. I just want you to take 30 seconds and think to yourself, which of these do you think you're good at, and which of these are you kind of iffy? Just think to yourself. Okay, good. And that's just for you. Remember, you're gonna have 25 minutes only to use or answer and use all of these different skills. So here are some thinking questions that are helpful for when you're dealing with these long FRQs. Could I get Heidi to read these out?
What content is the question related to? What is the question asking me to do? Explain, calculate, predict. What quantitative information am I given? What equations can I use to help answer the question? What scientific reasoning can I use to answer the question?
Thank you, Heidi. Now, these 5 questions are questions you should be thinking when you're going through the FRQ. If you want to actually just save your screen, so you can take a look at these while we're doing the FRQ, that might be a good idea. Actually, I'll keep these up when we go back to the FRQ. But for now, really, remember, you want to have these questions in mind because you don't want to default to your resource. You don't want to go immediately to the internet or your notes. You are your own best resource, and everything else is just something to help you and your own content knowledge. Good. For annotations, because it's all online, you might want to use the online annotation tools, like the highlighting tool. But for a lot of us, I think the paper annotations are the best because that's what we've been practicing and that we're the fastest at. But whatever system you choose, just make sure you are practicing that way consistently going forward if you want to use paper or if you want to type. Good. So now we're going to move on to our FRQ. For the long FRQ, the 25-minute FRQ, the first question, I'm going to suggest you take 6 minutes to read and annotate because there's going to be a lot of information and it's going to be challenging. You're going to want to go through all your thinking steps and answer each of these 4 questions in order to fully understand before you start writing. So actually, let's start that now. You can take a look at the FRQ in your Google document. We're going to take 6 minutes to read and plan on a separate piece of scratch paper. I'm going to set a timer for that. Great. We'll come back together in, say, 5 minutes, 30 seconds. I know. Remember, you are not solving anything right now. You are not answering the question. You are reading it, analyzing it, and annotating. Only that. Note that it does extend onto 2 pages. If you want to type your response, there's that box, but no one is answering. 4 minutes have passed. At this point, you should have been able to read through all the questions at least one time, taken some quick annotations, and now I need you to think about how you're going to plan your response. Keep the 4 thinking questions in mind that are projected on your screen. When in doubt, go back to the questions. All right, and track back up here. We are done reading, annotating, planning. We are not moving on to solve yet. Before we do that, I'm going to code call a couple of you students for your answers to these thinking questions, just to ensure that you are using the thinking questions in your process. So let's start. Ahad, I'm going to ask you to share your response for the first question to letter B. And then after that, I'm going to ask Ramir to share his response to the second question for letter C. And then we'll maybe do some more students after that. Starting with Ahad.
Okay, so the content that this is related to, since we're trying to find grams and it gives us a given number, you know, it's obviously you're gonna have to do some kind of stoichiometry. And because of that, you're probably gonna need the molar mass. And yeah, basically that's what I've done. I said that there's gonna be some kind of stoichiometry involved, so I started looking for pathways.
Good, very good. Just by identifying the topic, you can start to think, to move on with your thinking. Ramir, could you share your response for the second question for C?
My thought process was like really similar to Lukman's because I figured there will also be, it's asking about limited reactant. So I knew that there will also be some type of like stoichiometry involved. Yeah, so like it gave you your concentration and your volume. So I knew like off that I could get the number of moles of my solutions, and then I could probably just use those to find number of moles of one of the products.
Good, thank you. It's important that we are using these 6 minutes to plan our responses. Don't just assume you'll know how to do it when you get there. Write it down, take some time. If you can actually go through for each question and answer these 4 questions, you are in a great place to answer. But now it's 10:35. We're running a little bit tight on time, so we're going to move straight to answering. Take 16 minutes to answer this FRQ. If you have any questions, comments, or concerns, please raise your hand during that period. For this practice, feel free to use your Unit 7 study guide. And make sure you're pacing yourselves. We don't have the big clock in the classroom, so you have to keep an eye on the timer. I'm going through your Google Documents class, and I appreciate the number of students I see using highlighters to pick out important information. I see some students that are adding comments as annotations. Fantastic. Oh, I like the different colors idea. It pops, definitely. Oh. I see Gianna is marking the questions she's finished, so she knows not to bother reading them again. That's clever. Good. I like that. Hmm. Jawad, can you just type me your question? If it'll take too long, just send like a N and then I'll unmute you. There are fewer than 3 minutes remaining. It's time to answer one more question and maybe another one if it's an easy one. Make sure you use every second. Oh. Sorry, Ramir, I meant to send that to Jawad. And that is time. Please put down your writing instruments, stop typing on your keyboards, and track the screen up here. And I'll explain what's going to happen next. So there are only 4 minutes remaining in this period. I am going to quickly show you the answers to this FRQ. If you have a different color of pen or pencil, please use that to mark this down so that when you submit your photographs tonight, I can see what your original work was and I can judge your original proficiency. As I go through these, just jot down the answers and the corrections. Your homework for tonight, or rather, your exit ticket for today. You're going to take one of your FRQ questions, and then based on the correct answer, you're going to revise it to make it correct. That's your exit ticket for today. And your homework assignment due tomorrow night is the Unit 2 study guide. Okay, let's go through these. Okay, so for part A and B, +1 is A. And if you got that, you got the answer. And then for part B, I didn't need to see the work because we're adjusting to the new AP standard. But I did need to see the correct answer with grams and the species. So that's only 1 point here for the number with grams and N2S2O3. If you didn't get either of these, add it to your study guide. Here we go. Here's our limiting reagent. And then here's a verbal justification. This is all based on the mole relationship here. For your final answer, 12.5 degrees Celsius, it needs to be 12.5 degrees Celsius. 12 degrees Celsius or 13 degrees Celsius is not enough. You need to use the proper number of significant figures here. For part E, our answer is 749 joules, and that's the Q equals MC delta T equation. As long as you use the proper temperature from part D for this, you would earn that point. Who's calling me? Sorry, students. Oh, I know it's calling. Okay, and then for part, for part E down here, a long bit of work to get negative 1.20 times 10 to the third kilojoules per mole of reaction. I need it to be in kilojoules per mole of reaction. We have to have and it has to be negative 100% proper units. And then for part F, you could either use the mathematics for delta H to calculate that, or you can just use your understanding of the concentration and the number of moles present. Our net ionic equation down here. In the equation, sodium was a spectator. Sodium didn't change, it just moved around. Hydroxide changed, it went from hydroxide to H2O. S2O3 reacted and it became SO42 minus. The OCl lost its O, became Cl. So they're all active, they're all participating in the reaction, but Na didn't really participate. And that is the answers. I'm going to post this PowerPoint with the video for today's lesson. So if you didn't quite get that, you'll be able to see that later. And then your exit ticket is just pick one of these questions you got incorrect, revise it, and then answer the 2 reflection questions for that one. It's 55, so if you need to go, you can. I'm going to stick around for 5 more minutes to answer questions, comments, or concerns. Let's start with Ramir.
All right, so I had 2 questions. So the first question is, so like if we get a question like the one with the graph and it was talking about temperature, should we just, because it said temperature of the reaction, so should we just assume that it's talking about the temperature of the surroundings?
Ramir, it is not possible to measure the temperature of a system. You can only ever measure surroundings. So this graph, the only thing it can measure is the surroundings. So you have to assume the opposite is true for the system. Does that make sense?
Okay. Yeah, and then so for, like when we're finding the value of Q, should we still be saying like for like the purpose of AP, should we still be saying released or absorbed, or should we put in positive or negative?
For the value of Q, I would prefer you continue with released or absorbed, just to keep that consistent with what we've been doing. The sign is just a convention, so it is just another way to say released or absorbed.
Okay, thank you.
And then Sandra?
Hey, Mr. Geller.
Hello,
So, for numbers that E2, were we supposed to have it like 1.20 times 10 to the third? Because I put 1,198.56. Is that okay?
Let me just take a look. As long as the question didn't specifically ask for scientific notation, you should be fine.
Okay.
It's just that's how scientists write, so that's how our answer keys usually are.
Okay.
Yeah, no, it wasn't asking for that. So as long as you have the proper number, it didn't need to be in the question.
All right. Thank you.
Great. Gianna?
For the exit ticket, can we just turn in our corrections to the problem, like as a separate document, like a picture, how we usually do the homework?
Oh, yeah, that would be fine.
Okay. Thank you.
Mm-hmm. And then Kamani?
My question is, can you go over really quick the net ionic equation in part G?
Okay, yeah, the net ionic equation. So first I'm going to pull up the actual finalized equation here, and then I'm going to see if I can also pull up the original equation at the same. You know, I'll just make this real big. Make this real big. And you don't need to see this. You don't need to see this or that. Okay, so our equation here. Where'd it go? There it is. So our equation here, we have, I actually don't know what the name of that polyatomic ion is. We have N2, S2O3 reacts with NaOCl and NaOH to form Na2SO4 and NaCl and H2O. So a couple of things here. First, we note that there is a liquid present. H2O is a liquid, so we know that whatever species made H2O, they are going to be active participants in the reaction and will be present in the net ion equation. So I know that hydroxide can react with hydrogen to form water. So since it's the only source of hydrogen, it's probably going to be two hydroxides reacting. So I know that OH is going to be an active ion. I see that I have S2O3 and OCl. And then I have SO4 and just plain Cl. OCl minus is a polyatomic ion. So if that polyatomic ion splits, it's an active participant in the reaction. So Cl is still a participant because it broke off from the OCl minus ion. And then it formed NaCl. And then the O from NaOCl reacted with S2O3 to form the SO4 minus. Because S2O3 reacted, it was an active participant. In all of these cases, sodium did not combine covalently with anything. Sodium was just an ionic compound that, since we have only aqueous reactants and sodium is only in aqueous products, it never actually reacts. It stays aqueous the entire time. So it would not be part of the net ion equation. Does that make sense?
A little bit. I'll
Okay,
try to yeah, I'll figure that out.
The biggest thing, the most important thing here, Kamani, is to recognize that sodium was aqueous the entire time and therefore would not be an active participant and would be a spectator.
All right.
Okay. And then let me see if I can pull the chat back up if there are more questions. Anyone else? Okay. In that case, it's 11 o'clock. You're a little bit late to your next class. Have a great rest of your day. Okay, this should not be pop. This should not be up. Oh,